All right, today we're going to do something pretty cool. We're going to follow a single drop of water on this incredible journey, from right here on the ground all the way up into the sky to become something we see, well, almost every single day, a cloud.
I mean, have you ever actually stopped and wondered, how do they get up there? It sounds simple, right? But the answer? Oh, the answer is this amazing mix of sunshine, temperature, and believe it or not, even tiny little specks of dust. And this whole thing is happening constantly all over the planet. So here's what we're going to do. We're going to break that whole journey down. First up, we'll figure out what clouds are actually made of. Then, we'll walk through the 3 key steps of how they're born. And finally, we'll get into why these big floating masses of water are just so important for, well, for all of us. You ready? Let's dive in.
Okay, first things first. When you look up and see a cloud, what are you actually looking at? I know they look like big, fluffy pieces of cotton, but nope, it's something else entirely.
Yeah, they are definitely not solid. A cloud is really just a giant collection of millions, no, billions of tiny little water droplets or ice crystals. They're all just floating together up there in the atmosphere, and they're so incredibly small and light that they can just hang out up there, no problem.
And you want to hear the really mind-blowing part? The raw material, the stuff that makes every single cloud, it's already in the air all around us. Right now, even on a perfectly clear blue sky day. It's an invisible gas called water vapor. So the whole process of making a cloud is really just about turning this invisible stuff into, well, a visible wonder.
Okay, so let's follow that journey up into the sky. It's basically a 3-step process that takes water from down here on the surface and turns it into those clouds we see way up there.
And here they are, the big 3. Evaporation, which gets the water up into the air. Then cooling, which gets it ready to change. And finally, condensation, that's the magic moment when the cloud is actually born. So let's start with step 1.
It all kicks off with our good old friend the sun. Its energy beams down, warms up the water on the surface, and gives those little water molecules enough juice to just escape. They turn into that invisible gas we were just talking about, water vapor.
And I mean, this is happening on a huge scale. We're talking about the sun constantly lifting water from oceans, lakes, rivers, but it's also happening in your own backyard. From the dew on the grass or even that little puddle on the sidewalk, it's happening everywhere.
Okay, so now you've got all this water vapor mixed in with warm air. And you know how a hot air balloon works, right? Warm air is lighter than cool air. It's the exact same idea here. This warm, moist air is less dense, so it starts to rise. It begins its journey up into the atmosphere.
And that brings us right to step 2. Cooling. As our little pocket of air climbs higher, the pressure gets lower and it starts to expand. You know, kind of like when you let air out of a tire and it feels cold? That's what's happening. This expansion makes the air cool right down. The higher it goes, the colder it gets. Simple as that.
Now this cooling part is the real trigger. It's the secret sauce for making a cloud. See, air can only hold so much of that invisible water vapor. And as our air pocket gets colder and colder, its ability to hold that vapor just plummets. It's like a sponge that's getting squeezed. It's getting way too full.
So let's recap. The air is high up. It's gotten really cold, and it's absolutely packed with water vapor that it just can't hold on to anymore. The stage is set for the grand finale of our little droplets journey, the birth of a cloud. And here it is, the final, most important step, condensation. When the air cools down past a certain temperature, it's called the dew point. That water vapor literally has nowhere else to go. It has no choice. It's forced to change from that invisible gas back into tiny, visible little droplets of liquid water.
But there's a catch. It can't do it all on its own. The water vapor needs a little something to cling to grab onto. And that's where these microscopic particles floating around in the air come in. They're called condensation nuclei. A fancy name, I know. Just think of them as tiny little seeds that a cloud can grow on. We're talking about specks of dust, little bits of smoke, even tiny salt crystals from ocean spray.
And just like that, a cloud appears out of what looks like nothing. One tiny water droplet forms on a speck of dust. Then another one joins it, and another. Soon you have millions, then billions of these droplets all clustering together. And once enough of them get together, bam, they become big enough for us to see from way down here on the ground. And there you have it. A cloud is born.
Okay, so if they're all made the same way, why don't all clouds look the same, right? You've got the puffy ones, the flat ones, the wispy ones. Well, the basic science is the same, but different ingredients in the recipe create very different results.
It really comes down to how high up they are and how cold it is. So you've got your classic cumulus clouds, right? Those are the low, puffy, cotton ball-looking ones you see on a nice day. Then there are stratus clouds. They're the ones that form in these flat, gray sheets that just cover the whole sky and make it feel kind of gloomy. And then way, way up high, where it's freezing cold, you get cirrus clouds. Those are the really thin, wispy ones that are made completely of tiny ice crystals.
But what happens next? What happens when this process just keeps going? Well, inside that cloud, all those little droplets are bumping and crashing into each other. They start to merge, to combine, getting bigger and heavier, until eventually they get too heavy to just float around anymore.
And, you guessed it, that's when they fall back down to Earth as precipitation. You know, rain. Or, depending on the temperature up there and on the way down, it could be snow, sleet, or even hail. This is a huge, vital piece of the Earth's water cycle.
All right, so we've seen how clouds get made and how they give us things like rain and snow. But honestly, their importance to our planet is so much bigger than just the daily weather forecast.
I mean, they are absolutely essential for life on Earth. Think about it. They're kind of like a global thermostat, right? Their bright white tops reflect sunlight back into space, which actually helps cool the whole planet. They're also the massive engines that drive our weather patterns. And, of course, they're the delivery service for all the fresh water that every plant, every animal, and every single one of us needs to survive.
So if you remember just one thing from all this, let it be this simple little process. Warm, wet air goes up. As it goes up, it gets cold. And as it gets cold, that invisible water vapor turns into visible cloud droplets. Rise, cool, condense. That's the whole magic trick. Evaporation, cooling, and condensation.
And I want to leave you with one last thing to chew on, a really fascinating puzzle. We know that clouds reflect sunlight away from the Earth, which cools things down. But they also act like a big blanket, trapping the heat that's rising up from the surface, which warms things up. So, which is it? Are they cooling us down or warming us up? That, my friends, is one of the biggest, most important questions that climate scientists are trying to answer right now. It's something to think about the next time you're just looking up at the sky.